Hi, everybody. I'm talking today on face recognition and Postgres. Why would I want to do that, and who am I? I am Kobus Wolfhard, and I've got an engineering and AI background. We run a medical software company. I have too many kids. I can't remember the names, and I need face recognition to help me with that. And I needed a talk, so it will demonstrate a lot of Postgres features. This is not a talk on face recognition. I will only briefly touch on that because it's actually a fairly easy process and a fairly easy thing to solve. So once you understand that there's libraries and you can go, if you're in Python, you can go import face recognition, recognize, done. Then it boils down to what makes Postgres cool and why can we do this in Postgres. So why are we playing with face recognition in the medical market? There's a couple of reasons. Cameras are widely available and cheap as opposed to fingerprint readers and iris scanners that are not. Software libraries have just exploded. There's DLib, there's face recognition, there's a whole host of libraries that'll just do the job out of the box. And I love copying stuff, using implementations. People often load avatars, apart from likely actually a large percentage of this style crowd might not want their faces in a database. But most people are quite happy to put their whole lives on Facebook and Twitter and everything and pay the consequences. So in patient imagery, and specifically in medical legal terms, you want to make sure that you're working on the right patient. So if you have someone and you think you're dealing with John Smith and it turns out you're on the wrong John Smith and you give him penicillin when he is in fact allergic to it, you can kill him. And we've had a situation where one of our doctors luckily recognized that the patient's on Discovery and asked him about Discovery, and the patient said, no, I'm on Momentum, and it turned out he's on the wrong patient, and it turned out the patient actually had the allergy, and had there been a little face there, the doctor would have been able to walk out and say, hi, Mr. Peterson, like he actually remembers him. But yeah, that's a nice little added service. And secondly, he would not have killed the patient. Well, he luckily didn't, but he could have. And then obviously, it demonstrates Postgres' abilities. So ethical issues with face recognition, get consent. Whenever you're dealing with Poppy, get consent. There's a whole world of terrible poppiness. Once you get consent, Poppy is easy. When you build these systems, try and improve someone's life. Don't build it for the NSA, build it for doctors. We're hoping we're doing good, but we'll see. Store only what you need. So in our case, we want a small little photo of the patient so the doctor can recognize them, but in many cases, you only need to store a hash. You effectively get a hash of the patient's face or the human's face, and then get consent, really. Try and do that. So I'll first cover just very high level face recognition. I don't know all that much about it, so please don't catch me out. You get two main types, or used to, geometric and photometric. So pretty much you've got an image, you do a transform it, and you get some kind of a hash, a number series or whatever. So a photometric system would be like eigenfaces. And if you look at it, the first photo in the series is the average of all the photos. The second one is the average after you've taken off the first one, and so forth, the way eigenvalues work. Same basic concept. And then effectively what you do when you get a new face is you take the first face and you take off some percentage of that face from the image, and then the second and third, and you get a series of values, and that gives you some mechanism to recognize by. It's not rotation invariant, it's not wonderfully color invariant, but it is a fairly simple technique. One of the problems is you have to retrain every now and then with your population, and when you get to 1 million people, that's not a fun experience. And then the second one is feature extraction. There's a whole host of them, principal component analysis and whatnot, where effectively, like you can see on that little picture there, you find kind of where the eyes are and the ears are and things like that. It is not great for sideways rotated faces. It's also not great when you don't have a lot of resolution, because you actually need to find values fairly accurately, but then basically use the ratios of the face to try and find the person. When you watch movies, it's often kind of they have this stupid little thing they overlay and pretend that they're doing this. And then what I'm going to be presenting is stolen work, basically deep learning. Deep learning solves everything. We don't know why it works, but it works. So let's put it in cars and hope people don't die. But that's effectively what it boils down to. I don't know if any of you saw that thing about the recognition of dogs versus wolves, and when they try to find out why the image makes mistakes occasionally on dogs, it turns out a dog and a wolf is the same thing. If there's snow in the background, it's a wolf, and if it's not, it's a dog. And wait until the first car thinks a baby carriage is a I don't know what, and hits it. But in any case, we'll deal with that in time. Basically, you take a deep neural network. This I'm showing a convolutional one, but effectively you push in a face, and what they've done is they've trained it with the same face twice, 2 copies of the same face and 1 other face, and they've trained the output vector of 128 values to be the same for the 2 that's the same person and different for the other one, and they just kept doing that. And at some point you get a face hash, effectively 128 values that represent you. What does it represent? We have no idea. We actually have literally no idea, but it's fairly rotation invariant, and it's a decent technique. Okay, so why am I talking about face recognition in a Postgres conference? I am not. I'm actually talking about Postgres. So what makes Postgres an amazing database? The fact that we have languages. We can extend it. We can put just amazing stuff within triggers. Whether that's a good idea is debatable. We do a lot of that, and we think we're quite clever when we do that. But we'll probably find out in many years that that's not always the best solution. But we use a lot of Python, and you can do amazing things. We supplement old systems that can't properly talk to the internet by talking to Postgres and having Postgres do the submission or the building of XML or the parsing of XML, the parsing of JSON, or pretty much everything. So we use a lot of Python, wonderful language. There's a conference in a couple of days, maybe attend it. Perl, if you're that way inclined, you like writing 1 line of code, because you can always do it in 1 line in Perl. You've got the SQL, the built-in PSQL language and SQL languages, very powerful, not as standard in terms of normal programming language, a little bit more SQL-y, but it's quite nice to use. And then Tickle, that's the 4 built-in default supported ones, and then all the others are also built in, but they're contributor packages. You can do Java, Lua, R, Bash. Who would want to do Bash? But in any case, JavaScript, if you are actually a devil worshipper, that happens. We don't discriminate at this conference. And there's more contributed ones. I am fairly sure you'll be able to find Go and all those. I've not gone and looked because I love my Python. That's not any kind of sexual innuendo. That's like Python, the language. Any case, you can also extend with custom modules. You can build with C, C++, you can compile in. It is a massively, massively extendable database, and that's, I think, part of the power. The second you're a big corporate and you've got muchos programmers, you can throw them on some kind of a module and customize your system nicely. Okay, then we're getting to data types, and people think, okay, some numbers, some string, maybe a datetime, but Postgres is amazing in what you can do with this. So obviously we've got the numbers, we've got the typical integers, the numerics. There's a whole world of joy there. You can do arbitrary precision on a numeric. Things like money has some intelligence in it, the way it calculates change and how it deals with outside of the values outside of the resolution of the currency. Then we've got strings, varchar, text. Obviously you've got char. You can limit it. You have text that's nigh on unlimited. You've got things like CI text, that is case insensitive text, so you can input some stupid case, and when you recognize, it'll happily recognize because it effectively lowers it. And it's just a little wrapper that sits on top of text that makes the recognition easy. So if you were to do this in your program, something like CI text, you would literally write lower value equals lower, and you will build lower indexes, and you would just spend a lot of writing little bits in your queries, remembering to put in that lower when you search. And as soon as you use CI text, it just happens automatically everywhere on that field. And that's kind of, I think, one of the powerful places in Postgres that often doesn't get used. Daytime, date, timestamp, time zones. You can get day of week. You can do ranges. It is just magical. I don't want to calculate whether something's a Monday, but in Postgres, I just say extract, and I just, boop, it pops out. It's wonderful. Day of, a week of year, it's just amazing. We've got the document stores. If any of you have worked with HStore, XML, JSON, or JSONB, it's amazing. It changes your life. It is MongoDB in a row. It is the reason for being. I mean, it's a toss-up when I have to choose between family and JSONB, which one I love most. You can index inside of JSONB. You can search better than a document store JSON-style DB. Postgres searches better in it than the actual DBs built for it. It's just amazing. It is really what they've done there. It definitely involved a lot of goat's blood and black candles and stuff, because it is ridiculous being able to search multiple levels down within a document in an indexed fashion. Attend the JSONB talk later today. It's worth it. But with XML, you can build XML. You can query into that XML with XPath like it is a database on its own. It is truly magnificent. Enums. Who here has ever used an enum in a database? Ah, great. So yeah, nice feature. It actually allows you to sometimes remove the master detail thing when it's fairly static. One of the things to remember about enums, it's one of the only things that you can't transactionally append to the database. All other schema changes transactionally, but enums don't. Don't know why, but I'm sure there's a good reason, and go to the US conference and ask one of those people. There's geometry types where you can do lines, you can do circles, paths. I don't use any of that, but you can do contains within, all kinds of fun things. What we use there is actually that's not even part of those parts, but I'm sure it's because of those guys that it was built. When you've got two GPS coordinates, you can feed them into a function, and Postgres will tell you how far on the curvature of the Earth those 2 points are from each other. So kind of searching for a doctor nearby that would be a fairly handy thing if you're not going to hit Google. Network types, for some reason they have that. I've not found it all that useful, but if you're working with smaller subnetworks, it becomes hard to know whether something that ends in a .24 is actually a valid IP address when you're in these sub-ranges, and again, here it'll help you. Range types, most of the base types, you can do time, numbers, things like that. You can put in range types, and you can actually query, is it in the range, is it contained within, does it overlap, doesn't it overlap, little things like that, so fairly nice. And then you've got arrays. If any of you have used an array, it is a document store on its own. Until you found out about JSONB, you were probably using arrays. We were. And cubes, which I'm assuming none of you will actually know, but it's basically arrays on steroids. And then you can actually build your own custom types. You can very quickly define a type. You can base it on JSONB, put some constraints on it. Very, very, very nice. Extendable, wonderful DB. Contrib module, if any of you have worked with that, the admin pack allows you to access your log files through the interface. Auth delay will allow a quick delay. All kinds of fun little things which just makes your life better. Go look in the Contrib module, read up about it. There's cool stuff there. CI text, I've mentioned. Cube, checkpass, it's all added types that'll happily decode or decrypt the field checkpass. Cube will make vectors just... It'll just take an array and give you a distance metric, and we'll get to why that's important in a second. And CI text I've discussed earlier. Index types, Bloom, btree-gen, btree-gist. There's just a shed load of those kinds of indexes, and it'll make your life better. You will take a query that takes 100 seconds, and you'll bring it down to 10 milliseconds, and you will just think you're the best thing ever. But actually someone else did all the work and you're just copying it. DB-link, foreign data wrappers and file data wrappers. Have any of you used that? Wonderful, isn't it? It's just the most fun thing to not even have to connect to a Microsoft SQL database, but to do it through your Postgres. If you've got files, you can import directly. You can add them as if they are tables, CSV files, and work with them, write to them. It's just, again, Postgres is amazing. It is the best thing ever. Well, maybe I just drank the Kool-Aid, but really. LSN, randomly picked that up while setting up the talk. It is barcodes. So it'll validate your barcode types, and you've got different legal methods, values and stuff. Don't know about barcodes, but There's a module. It'll solve the problem for you. PG stat statement, PG buffer cache. The people coming tomorrow to the training, we will be encountering that. PG stat statements is the single best thing to optimize. Pretty much. Optimize all your queries. Well, find out which queries offend your database. You add that as a module in your config file, restart, and then you say, select star from PG stat statement, order by total time, descending. Limit 1. There's your most intensive query in your database, and you know what to optimize. PG buffer cache allows you to check how much different tables use the shared memory, allowing you to actually tweak your database. Trigrams, if you've not worked with that, it'll allow you to search within, it'll speed up I-like searches where you have a percentage at the start of the I-like and at the end of the I-like. So basically you have free text index searches. It is, yeah, it's large, unfortunately, but good. Table func crosstab, if you've not used that and you've ever used Excel and done a pivot, fairly similar to a pivot, not exactly, but yeah, and there's much more. Okay, so how did we do our face implementation? We started off with a Python dlib wrapper. We took one of those fun little pre-trained neural nets. We put the Python inside the Postgres wrapper, and then we used the cube type. The cube type will take a vector of pretty much an array of, say, 128 values that represents a face, and it'll give you a distance metric. And that is effectively what we need to be able to do to compare those faces. We compare the Euclidean distance between those two sets of vectors. So pretty much it boils down to two PG functions and a bunch of terrible JavaScript code. I'm not that good of a devil worshipper, so please do be kind when you get to that point. I'll give you the site in a second, and you're all going to take a little picture of your face and load your name and then try and find yourselves. Who knew? So karmic. Okay, so basically we added PL Python 3U, and we added a face hash. I'm calling it a fash, because face hash is too long to type for some reason. And then I did add extension cube. Cube gives us the distance queries. It gives us indexes on distance. You can do taxicab. You can do least squares. It's actually fairly nice. From 9.6 on, you actually have the arrow middle thingy. Looks like one of those X-Wing style fighters or something, operators. And yeah, there we go. Create extension cube, create table face table, name, image, cube. Oh, fash. Obviously, this will look a bit different, but in your case, when you do use it, we've got a quick trigger, import base64, import face recognition. Actually, it's not a joke. That is literally what you do. And then we do fash equals face encodings. Find the first face. So when you are registering yourself, only make sure your face is in there. If it finds your face, it'll do that. It'll create a fash and it'll pop into the table. That's it. That's it. There's a second function defined where I feed an image to it and where I'm just going to render the names on it. And if you take out your phones, get on the internet and quickly go to either the bit.ly, which will redirect you to that one. You can quickly register your face. You would type in your name, you take a little picture of your face. If it fails, it'll give you a sarcastic comment, and you'll have to retry. And then pretty much after that, it redirects you to the second URL, and you'll be able to find faces, and it'll actually draw the name of the face on there. It is actually not built to recognize faces. It'll find the closest face. So it might end up, if you're not in the system, finding someone else. So yeah, it's not perfect, but yeah. So let's quickly, I'm going to do this on mine. So this is one I did earlier where I recognized a bunch of faces, and it's not all that pretty, but if you were to go to that URL, it'll find you a name. I can just go blah, 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 and try and look at the camera, capture. It'll wait there for a second. This is actually just copying up. At this point, you've done your bit. If it progresses to this site, basically your face is registered. And at this point, I can do a quick recognition, and it will find me as blah, 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 blah. So if some of you guys have registered, I'll happily try and find you. Oh no, this is not going to be big enough. Yeah, it's not even finding the faces. If it doesn't find your face, it'll render as unknown. But yeah, you can now play with this. Just go back to this. And play with that in the meantime. We can search about in a million faces. Okay, we fake generating the data to have a million records, but we can search and find the most matching faces within a million records in about 1,200 milliseconds. And that is on my home, well, my work desktop. It's an i5 with 32 gigs of RAM and an SSD. So it's beefy, but it's by no means anything the NSA owns. And if you're thinking in terms of a million people, that's a good chunk. And it scales fairly linearly. So 10 million people would be about 10 seconds. And if you were to parallelize that, you'll likely get it quicker. There is an index that you can build on it. It makes it slower. Don't know why, but the fact that they do say don't make a cube longer than 100 values, and we're at 128, might have something to do with it. I've not been able to engage with the author just yet. Not answering. Sucks, but okay. So yeah, the power of Postgres. It is the programming languages. It's the extendability. It's the data types. Seriously, look into the data types. There is muchos great data types. Custom extensions, did I mention data types? Any immutable function can be turned into an index. So you can have a document store, and then you can build a function that goes and fetches a certain set of values, adds them together, and transforms them in some magical fashion, and you can build an index on that. And that is quite powerful. That really allows you to search your data the way you're accessing it, and actually to search on a computed value effectively, as long as it's immutable. The gin and gist style containment queries, both on the JSON side, within arrays, distance metrics. It is magical. It makes things that used to take minutes take milliseconds. And yeah, I almost forgot data types. Really, really amazing. Questions? Have any of you been able to register your faces on the system? And then just do after that a quick recognition of your face? Ah, one there, cool. So what we should probably do is have little goggles, like a Google goggle, that does that for us and fetches off of Facebook. That would be pretty cool. But yeah, questions, people? No questions? Not a single question? Okay. Okay, cool. Did you guys know you could do this with Postgres? Yeah, because you sit in the same office as me. Okay, so I think we are fairly early because I tend to rush through things. So I might have almost hit my target of 40 minutes. Ah, yes, sir. Is it a quick question? Okay, yeah, so can I tell you a little bit more about the cube type? So the cube type is effectively a wrapper on top of an array. Well, not a wrapper, it's its own type, but it looks like an array. You can have multiple dimensions. You define the size, and you're not allowed null values. It must be filled in. You can have the whole value null, but once you actually insert an array with values, all of the values have to be filled in. Unlike an array where you can have a null in position 5 or whatnot. And then it provides a bunch of things, distance searches. So it's all about effectively cube transforms. In this case, I'm using it as an array transform of sorts. But there's quite a few operators that just does a lot of heavy lifting regarding transforming of cubes. So what this boils down to for me, and why I'm interested in it, is literally the distance metric that you have, because the size of it is fixed, because it's not, you can't have 150 and 150, it must be the same size. You can actually do distance metrics between them, and yeah. So, but that's unfortunately all I know. Yeah.
Would you be able to do like matrix multiplication using?
I did not look at it. Looked like it had it, but I wasn't interested in that, so I passed over that bit in the documentation fairly quickly, but it did look like it has that built in. But you might want to double check Like I said, I scrolled past that to the distance. So unfortunately, I've not used it for anything else. And but if you were to ask me now, how would I approach matrix multiplication, I would be going to cube and trying to start there. I would assume that they will have that in. More questions? Okay, awesome. Well, you guys need to enjoy Postgres, the PostgresConf, and yeah, thank you.